Right, let's start today's session. In the last session, we were discuss about data structures of Python and basic data types and sequence data types we discuss. In that, we have seen what is string, how to create string, and what is list and its rules and regulations, and tuple. And today we'll see set, dictionary, and then range. So set is unordered collection of elements. Set is unordered collection of elements. Set is unordered. See, string is ordered, list is ordered, tuple is ordered. Means what order you mention while creating the list and tuple, same order it's going to display. But when it comes to set, it is completely unordered. Unordered collection of elements, that is set. Next, how to create set? We can create a set by using curly brackets. We can create a set by using what? Curly brackets. But to create an empty set, then we use set functions. Hello, Mr. Kiran. Please mute your audio. I request you, please mute your audio.
Hello.
Now you can see. Yeah.
Yeah, it's
Kiran,
not from my side.
that's I understand that. Kiran means you are not. One more Kiran Kumar Narla is there. I think I got voice from him. Okay. Yeah. One more Kiran is there. Sorry for that. So set is unordered collection of elements, and we can create a set by using these flower brackets. And to create an empty set, then we use set function. Don't use empty flower brackets because it leads to dictionary here. Because in Python programming, we can create dictionary by using these curly brackets. For example, look at here. If I try to create a set s equals to something, print s, print type of s. What type it is? It's not set type, it's dictionary type. Dict type it is. So to create empty set means set with no elements, then we have to use set function. Then it leads to empty set. This is an empty set. So set is unordered collection of elements. We can create a set by using curly brackets. And to create an empty set, then we use set function. And next, set will allow different data type elements. Yes, it will allow different data type elements. Different data type elements. But make sure that set is unordered collection of unique elements. That's better. Unique. Unique means no duplication. That means set will not allow duplicate. Set will not allow duplicate values. Yes, duplicate values it will not allow. Even if we give duplicate values or elements, then it will ignore. It won't give any error. It will ignore simply. And now, is it mutable or immutable? Set is mutable. We can change. Yes, we can change, sir. Changes are possible on set because some methods are there. Add method for adding one item. Update method for adding more items. Discard method for removing one item from the set. Remove method is there. Okay, we can delete the set. These all operations we can do that. It's a mutable object. Set is completely. So order is not unordered collection of unique elements. Let's create with set with elements like 10, 20. Okay, different values I'm giving, names and floating value I'm giving here. Floating value and character also. Okay, So once we run this, now you can see the order what I maintained while creating set, but same order it's not appearing here. It's completely different order. So this is different order and this is different order. So the data structure which is unordered like set that don't have any indexes. Indexes are not possible, sir. Here, indexes means just every collection is stored in index basis only. So consider this example. S is what? String. DURGASOFT I'm taking here. String is printer S of 0 index I'm taking. This is what actually string. String support 0 index or 1 index, 2 index. You can type any index like 6th index. S of 6 means 6th index, 6th position. What character is there? That character is there. This is S. String is a group of characters and it is ordered collection of characters. So that's what it supports. Index. Index through we can get the value. For example, L. L is a list. 10, 20, 30, 40. Suppose L of 1 index I'm taking. 1 is index. 0 index 10 is there. 1 index 20 is there. So it supports indexes. Are you getting my point? Now, tuple also ordered collection of elements. T. T for tuple. Just I'm taking tuple creation here with round brackets. T of index 1 or 2. Any index you can pass. T of 2. Second index, what item is there? 30. It's possible. So similarly, I'm trying to do set S. No, S is a set. Suppose when we try to print S of 1, S is set here. Index is 1 here. Now you can see set object is not subscriptable. Means index is not possible because this is unordered. We don't know at what time what order of the element is present. It is keep on changing the order. So that's what we cannot apply on indexes on set. Okay, note this point. Whatever the ordered collection of sequence, like string is ordered, list is ordered, tuple is ordered, it's having index, but set is unordered collection of unique elements. We cannot apply any indexes on set. So set is mutable. Mutable means even when we print this set values, we can add items to the set, like s dot add of, suppose 45 is there or 44. When we try to add this item to the set, set will have this item like 44. And we can remove the items also like by using discard method, like 10 item I am deleting here. So we can delete item from the set. Deletion is possible, adding is possible, like more functions are there, will come across. Okay, just for showing whether it is mutable or immutable, just I'm including this methods. And coming to this, what happens if I include duplicate values like 10 already there, and here it is there, here it is there, but it won't take duplicate elements. Simply it will ignore the duplicate values. Once I execute, now you can see we got this only one value here. One value is ignored. Okay, this is set operations, unordered collection of unique elements, no duplicates. We can create by using set, by using curly brackets to create set. And if you want to create an empty set, we use set function, and it will allow different data type elements, and it will not allow duplicate values. And mutable object, it is completely. We can change at any point of time. Now coming to the dictionary. DICT considered as dictionary in Python. So dictionary is a collection of items. Okay, and in dictionary, each item can be a pair of key and value. In dictionary, each item can be a pair of key and value, sir. Yes. Normally, item is nothing but, or value is nothing but one value. Like in the context of set, value is nothing but one value, like 10 or 20 or something. In the context of tuple and list also, values means one. But in the context of item, dictionary, item means key and value, both considered as one item. Dictionary is a collection of items. In dictionary, each item can be a pair of key and value. Key value pair is there. Key value pair. Okay. Now coming to this, in dictionary, keys are immutable. we cannot change, and must be unique. Keys are immutable and we cannot change and must be unique, means keys must be unique. In dictionary, values are mutable. Values are mutable. We can change the values and need not to be unique. Need not to be unique. Duplicate values also we can include, no problem. So dictionary is a collection of items. In dictionary, each item can be a pair of key and value. In dictionary, keys are immutable. We cannot change, and keys must be unique. No duplicate keys allowed. But in dictionary, values are mutable. We can change values at any point of time, but need not to be unique. Even duplicate values also possible. So that's what we cannot say directly. Dictionary is mutable object or immutable object. So both are there, no? In dictionary items, keys are there, values are there. But keys are having immutable nature and values are having mutable nature. But in dictionary, keys and values can be of any data type, that is according to mutable and immutable, no, any data type. Keys in dictionary, keys and values can be of any data type according to mutable and immutable nature also. Why? Because I said that keys are immutable. In the immutable part, keys part, we cannot include list part because list is mutable. That is also we have to consider. Okay. So in dictionary, keys and values can be of any data type, means general types like key can be an integer, key can be a character, key can be a string, key can be a float. At the same time, values can be an integer, values can be a character, values can be a float, values can be a list, values can be a tuple, values can be a set. So like this. So let's try to see the practical implementation. For example, D for dictionary, I'm creating empty dictionary by using curly brackets. Even you can create empty dictionary by using dict function also. There is a dict function. Using that also we can create empty dictionary. This is same and this is also same. dict is there. Okay, and you can apply dictionary values like 1, 2, 3, 4 like this. Now observe here, whenever I try to do d equals to 1, 2, 3, 4, and is this dictionary? No, it's completely set because we supplied only keys here. No, 1, 2, 3, 4. 1, 2, 3, 4 will be act as a keys only here. So these will be tried to treated as keys, set keys here. But these are don't have any combination key and value pair. So let me give key and value pair like 1 ID, name is this one. 2 ID, name is this one. 3 ID, name is this one. 4 ID, name is this one. Names can be of duplicate. Here same name, here same name. But once I try to do this, it's considered as dictionary here. And you can see, for example, one more key I'm taking. Key must be unique, I said. Key must be unique. But here one key is there already, again one more key is there. Any one key value pair is accepted. And values may be duplicate. Yes, two values are same, no problem. But keys must be unique and keys cannot be changed. It's fixed values. Values can be changed. You can change the values. For example, I'm trying to change the values here. Okay, D of how to change the values, compulsory keys through only. Suppose key 4 equals to, I'm changing the value here, printed D. Value can be changed here by using keys. So this value can be changed. Key cannot be changed, it's fixed key. And let's try to do this. Key can be of string or integer. Suppose
Hello.
integer is the key. Yeah, Smita, tell me.
Why it's not printing Sai, only printing Mohan, right?
Where?
Keys 1 1.
Because duplicate keys are not allowed.
Yes, I got it. But it's printing Sai, but it's printing Mohan, but not printing Sai.
See, if we have a duplicate key existed, randomly by default, any one key value pair is going to consider.
Okay.
but all the time not only one Mohan, but anyone. Sometimes it takes this also here. So randomly it will take one key value pair. One key is, two keys are there, duplicate is simply ignore. Same like set, we have set with the duplicate values. So one will be ignored, one will be considered as a uniqueness. Keys must be unique.
It will not throw error.
It will not throw error, yeah, that's what. It won't throw error. It's simply ignore. Same here, keys in set context we discussed, no? Even when we create a set, we have given some duplicate values and it's simply ignore. Here also in dictionary point of view, it will not throw any error. Simply it will ignore one key value pair. Only one key value pair will be considered as a key. Unique keys only possible. So if you want to change the values, we can do it, but compulsory we have to use dictionary keys only here. Keys through we can able to change. Values through we cannot able to do this. So anything if you want to do in dictionary collection, keys are important. Keys through we can do it, not values through. So this is dictionary and we have to discuss more functions on dictionary also. How to get the values from dictionary by using keys in different ways. How to delete some particular key value pair. Okay. What are the methods are applied on dictionaries? We have to discuss in detail. Coming session we'll talk about all. Just overview I'm giving here. Now coming to the range. Range is used to generate range of values. Range of by default range will start from 0. In case if you want to start with your range number by 1 or 2 or something, then we can do it. Okay, yes. Now you can see range is immutable here. Range is immutable. Once we create range of values, we cannot able to modify that. So you can begin your range values from any number, but by default it will print what? 0 onwards. So let's try to do this. But range will not print directly range of values and sequence of values. Range will not print range of values by default. Let's try to do this. R equals to range of 10. Just for example, 10. Range of 10 means what? 10 values. Print R. Print type of R. Type of R. What type it is? Range type. But is that printing range collection? Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? No. It's not printed range collection here. Can you please mute Smita?
Sorry.
Mute your audio.
Okay.
Yeah. See here, R equals to range of 10, print R, print type of R. So we are not getting this range of values. Only range is returning what type of range of values, like 0, 10. Yes, including 0, excluding 10. So you have to be, if you want to display range of values, you have to be convert this R into any other data structure like list or set or tuple. I'm just converting that into list or list values through we are printing this range of values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is up to 10, including 10 not. Okay, excluding 10 it is range of 10 means if you give 11, then not 11 here, 11. That is including 10 only. And range by default start from where? 0. In case if you want to start your range of values like for example 2 and I want to take 30. So 2 to 30 values I want to print. Yes, we can do it. And there is one more parameter is there, one more option, one more value, step value is there. For example, step I'm taking 3. Start value, stop value, and then step value. So it starts from 2 up to 30 values, it will generate range of values. And by taking step value 3, 2 plus 3, 5 plus 3, 8 plus 3, 11 plus 3, 14, like this. You can create any range of values like this. This is range, and more functionalities is not there, but rapidly we use this range function in our upcoming program using for loop or a while loop, anywhere you can use this range function here. It is used to generate range of values. For example, this range function repeatedly used for iterations. Iteration means if you want to print employee details, 10 employee details. If you want to accept values, 10 employee data at runtime. So range of 10 means it will ask you 10 times employee details continuously in for loop. Generally, we use this range. So these are data structures, and these also there. Here you can see bytes, byte array, frozen set also there. But at this moment, I cannot discuss about this because these bytes, byte array, frozen set not created by directly, because how we create range, how we create list, dictionary, how we create set, similarly we cannot create this bytes, byte array, frozen set. You have to create from other data structures, like bytes can be created from list, byte array can be created from list or set or tuple, frozen set can be created by using set only. So once I complete this all data structure in detailed discussion, at last I will talk about this bytes, byte array, frozen set, all these things. Okay, for sure that. So just overview I'm giving here. What is what are the important points. Now coming to this operators in Python. This is very simple concept, but it's very important. We have to use these operators also in basic programming. So generally every programming language is having some operators. Operators are used to perform some operations like arithmetic operations, logical operations. Okay. So these are all operators are there. What type of operators are there in Python we'll discuss. So operator is a symbol which is used to perform some required operation. Consider this is a plus. It's a symbol which is used to perform arithmetic addition. No? Like, so 2 plus 3 is there here, or 3 plus 2 is there, 5. So here plus and equal to are operators. Plus is for arithmetic operator, equal to is for assignment operator, assigning the values. And 3 and 2 are operands. Operators are used to perform operations using operands. So what are the operators are there in Python programming? Arithmetic operators are there. Next, relational operators are there. Logical assignment operators are there. Assignment operator. And logical operators, logical. And then membership operators, and identity operators, identity, and then bitwise operators here, bitwise operators. So all operators I'm going to use in my upcoming program. Everywhere I'm going to use these all operators, but except the bitwise operators. Bitwise operators also I'll explain you clearly, but I may not use these bitwise operators in our programming because bitwise bit calculations only we use this bitwise operations on integers, but it's not required for us really. But these operators are useful for us. In every way I'll use. But it look like simple, but it's important. You have to know that. So arithmetic operators are like this. Plus for addition, minus for subtraction, star for multiplication, and slash for division, and modulus. And double star is there for power, means base and exponent values through. Suppose 3 star 2 in the sense, 3 is the base value and 2 is the exponent value. 3 to the power of 2, that is 3 square, 9 will be written. And floor division it is, this is. Okay, plus addition, subtraction, multiplication, division, modulus, power, and floor division. So let's try to do this quickly. I'm trying to do here 3 plus 2, print 3 minus 2, print 3 star 2, print 3 slash 2. Any values you can take, print 3 star 2, 3 to the power of 2 that is, and then print 3 modulus 2. Modulus will return remainder and division will return quotient. You know that. Floor division will return exactly a round up value. It will remove that fractional part. You can see 3 plus 2 is given 5, subtraction, multiplication, division. This is what? Exponent, that is power 3 to the power of 2, 3 square 9. 3 modulus to 1. 3 floor divide 1. Because 1.5 is division. So it will remove this 0.5. This is fractional part will remove, and only this part will be integral part will be get 3 floor division. Floor in the sense reduce the value. Seal in the sense increase the value. Sealing and floor methods also there in math functions. Mathematical library is there. I'll talk about math library, okay, in the modules concept. So floor divide will return the value, round up value. It will not be considered 0.5 or something like that. Extra values will be the floor. It will be reduce the value. Division will exactly divide the values and return same value 1.5 like this. These are arithmetic operations. Only we can perform this arithmetic operators. Relational operators are there. Less than, greater than, less than or equal to, greater than or equal to, not equal to. These are all relational operators. And based on the relation, then it return Boolean. Yes, all relational operators will return Boolean values like true or false based on your relational. Suppose let us consider here print 2 less than 3. What is that 2 less than 3 is? Yes, it's correct. True. 2 greater than 3. 2 greater than 3 false. 2 greater than or equal to 3. Greater than or equal to any one. If correct, then correct. But 2 greater than 3 not correct. 2 equal to 3 not correct. If I say 3 greater than or equal to 3, yes, 3 greater than 3 not correct, but 3 equal to 3 correct. So similar. And 3 equal to 3 is correct. And 3 not equal to 3 not correct. 3 not equal to 3 correct. Not correct, it is false because 3 equal to 3 only, no? Not equal to you are using. And 3 not equal to 4 means, yes, correct it is, exactly. This is very simple and it's not big deal to handle, but it look like simple, but you have to use in our programming also. Now assignment operators are there here. So equal to is simple assignment operator. This is assignment. Plus equals to is nothing but add and assign. Add and assign. Minus equals to means subtract and assign. Subtract and assign. Star equals to multiply and assign. Multiply and assign. And slash equals to means divide and assign. Divide and assign. Assign. And star equals to floor, what is that? Power and assign, or exponent and assign. And modulus equals to means modulus and assign. And then finally floor divide and assign. Floor divide and assign, like this. So first I'm trying to do equal to, suppose a equals to 5. Just any value you can take. A equals to 5. Print a. Simple assignment operator I'm using. 5 will be assigned to a variable here. Immediately when I try to do a plus equals to 2, print a. What does it mean? A plus equals to is assignment operator. A plus equals to, or this expression we can also write like this: a equals to a plus 2, just for clarity. Either you can write a equals to a plus 2, or you can go through a plus equals to. Both are same. So a plus equals to means add and assign. Add means what? Right now a is holding 5. This 2 will be added to the 5 first. 5 plus 2, 7. Then 7 will be assigned later to the a. So this is called add and assign. Now it will become 7. You can also use this expression in case if you don't want to use this. Okay, same, a plus equals to 2, or same expression you can write a equals to a plus 2. So add and assign means first a is holding 5 here. 5, 2 value will be added to 5. Once 2 value is added to 5, how much? 7. 7 will be assigned to a. So this is 7 only. Next, a minus equals to 2 I'm taking, sir. A minus equals to means on which A variable it is affecting, recent value. Right now A is holding what? 7. On 7, this expression is going to affect. So A is having 7. 2 will be subtract from 7, that is 5. Then 5 will be added to A again here. It won't affect on A, 5, no. It is recent value only. On recent value it will affect like this. So this is what? Add and assign, subtract and assign, multiply and assign like this. Multiply and assign means again A star equals to 2. Print A like this. Print A. This is 10. A star star equals to 2. That means print A. 10 to the power of 2, 10 square, like 100 only. Okay. So this is what actually assignment operates. Similarly, we can go for modulus and floor divide also same. Assignment operators is all. And coming to the logical operators here. Logical operators are simple. AND is there. AND means both condition must be true. OR is there. Any one of the condition true. Not is there. Reverse the condition. That means complement. So, and return true. It return true. When it return true? If both the conditions are true. Both the conditions are true. Then else it return what? Simply false. OR means return true. Return true. If any one of the condition, if any one of the condition is true. If any one of the condition is true, or both conditions are true. Both the conditions are true. Okay, then else false means both conditions are false, obviously false one. Not means simple. It return true if the condition is false. If the condition is false, return false if the condition is true. So let's check out here quickly here. And or not. Suppose here print 2 less than 3, correct. 3 less than 5, correct. Both are correct. If both are correct, then what will happen? Condition is true. Suppose one of the condition is false, like 9 less than 3, not correct. 3 less than 5, correct. One of the condition is false, then obviously false, because AND will return only true if both conditions are true only. Otherwise it return false. Or I'm taking means, or in the sense any one of the condition is true, either this or this. But in this case, this is false, but here this is true. Because of this true, then it return true completely. Any one of the condition. If both conditions are true, obviously true only. Okay, or but both are false, then obviously false only. Like 9 less than 5 and 6 less than 3, both are false, then obviously false it is. And not in the sense, yes, complement, that is reverse. So if condition is true, then it return false. For example, 9 less than 5, it is false. If I say not 9 less than 5, not true means false, not false means true. Simple. Not I'm applying. Not 9 less than 5. Simple, it is true. And 1 less than 0. Actually false, but here I'm saying not, then true only. And 1 less than 6, false. Okay, 1 less than 6 is what? Correct only, but not means false only. So this is logical operators. Now coming to the membership and identity operators are there. So membership operators are used to check whether a value or any object present in given sequence or not. Sequence means it can be a list, it can be a string, it can be a set, it can be a tuple. Okay, what are the membership operators in and not in? And moreover, in and not are keywords. Yes, these in and not in. Not is a keywords only in Python programming. So membership operators are these. These operators are used to check whether the value or any element present in given sequence or not. If the value is present in given sequence, in will return true. It return true, sir. When it return true, if the provided value or any object, any object, any object, any object is present in given sequence, given sequence, given sequence, then it return true. Else it return what? Simply false. And same not in how it will work. Not in will work if really your provided value is not present in given sequence, then it return true. It return true if the value or any object is not present in given sequence, then it return true, else it return false. Let me check quickly here. Suppose I have a sequence called list sequence. I have the elements like this 10, 20, 30, 40. I want to check one of the values present in given sequence or not. Then we can use this print 100 in L. 100 in L. Is this 100 values present in L sequence, list sequence? No. So immediately it return what? False. 10 in L. Do you think 10 is present in sequence? Yes, 10 is there. Suppose 10 not in L. 10 not in L? No, it is in L. So it returns simply false. If 10 in L, yes, it is correct. Suppose 100 not in L, 100 value is there. This is not in L. Yes, really 100 value is not present in given sequence. So you can true here. So these are just checking whether your value or any element or object present in given sequence or not, it will check. If your provided value or any object, see in Python programming, everything is considered as object. That's what I'm considering. This value is called as object, or any item or any element we can call. And you can apply directly like this also. No need to take any sequence values. Suppose here print some x value I want to check, where x in DURGASOFT string. Do you have x value, x character present in DURGASOFT string? No. False. Suppose A is, I'm checking, A in DURGASOFT. In this characters, A is present? Yes, A is present. That's what, yes, true only here. So we can check the values present in given sequence or not. Any sequence, it can be a string, it can be a set, it can be a tuple. Just checking. Because sometimes what will happen if you do, if I try to remove the value or if I try to discard the value, sometimes if the value is not present in sequence, then obviously you'll get an error. So to avoid that error before performing some action, so better to cross verify with that collection whether your value is there or not. How to check whether the value is present in sequence or not, because of this membership test through is possible. So this is membership operators. Value is present in sequence or not, we can check in and not in. Then coming to the identity operators. Identity operators are used to check whether variables or any Python objects are having same identity or different identity. Okay, so same identity or different identity. So how we can check for that? Identity operators are there. Is not. Here is also a keyword, not is also a keyword. If the variables are having same identity, for example, is, it return true. If the variables are or any objects are having same identity, then it return true. Else it returns simply false. Similarly, look at here. If is not will return what? Actually true. When it return true, if the variables or any objects are not having same identity, yes, then it return true. Is not, else false only. Let me check quickly here this. Okay, is and is not are identity operators. Let us consider this. Look at here, a value 2 and b value 2, and I'm trying to find a is b. Identity is same or not? Yes, same. A is b, same identity, sir. You can see. So the reason is what? You can see both are having same value. When we go for 3, suppose a value 2, b value 3, Now this time you can see A is B. No, A is not B. A is separate and B is separate like this only. Are you getting my point? A is not B, for example. A is not B. What basis it is going to find identity same or not? Even you can check it, like for example, A value is Sai is the name and B value is capital letter Sai and A is not B. Yes, A is not B. A and B are both are different identities. So A is not B correct. A is B not correct. A is different identity and B is different identity here. A is different identity and B is different identity. False is there. But how it will be? So in Python programming, there is a built-in function available, sir. Especially when it comes to identity, there is an ID function. It is a built-in function. It is a built-in function which is used to find memory address of the objects. Okay, and it will return a unique integer, unique ID. That is integer only. ID function is a built-in function in Python programming, which is used to find the memory address of objects, and it will return a unique integer. So that's what we are finding, A is B or not. Suppose A value is I, B value capital letters I, but let me find the identity of this address of the variables are same or not. Print ID of A, print ID of B. So identity will be different, you can see, because these two variables memory address represent different numbers because values are different. So that's what A is B false. In case if I change this one as, now you can see A and B are having same identity at this moment. That's what A is B true. And even you can see 10 value I'm taking, 20 value I'm taking. These are having both different identity. In case if the value is same, then same location it will be arranged, so that will be identity will be same. So two variables are having same identity or different identity. How we can check? By using identity operators. Is not. Is written true if the values are having same identity or any objects are having same identity. Otherwise it written false. Is not written true if the variables or any objects are not having same identity, different identity, then it written true. Suppose A is not B. A is not B? No. A is B. False it is. But in case my values are like this 20, A is not B, yes, A is not B, correct. This is case correct because it is having different identity, this is having different identity like this. So these are all identity operators and maximum, these are basic operators. And in coming session, we'll talk about bitwise and also how Python execution process, when we start execution, what is going to happen internally. And when we assign the values to the variables, how memory can be allotted, memory management, how it is going to happen. We'll discuss in detail in next session tomorrow. Okay. And kindly note this point, and this link will not work for tomorrow's session. Okay. This link is expiring today. And please contact to DURGASOFT immediately for joining tomorrow's session. They will give you a new link. Okay. So other than this, if you have any question, please feel free to ask me now. So that's it for today from my side. If you wish to continue this Python package course, please enroll for this course by contacting to DurgaSoft. Mr. Kiran, tell me.
Actually, I have enrolled. I have taken